Good morning, room 22. We are going to delve into lesson 11.5 and discuss area, kind of estimating what you need to do with area, and we will measure a little bit and get you more familiar with that. We will discuss perimeter also a little bit as we continue on with our area and perimeter lessons. So what I want you to look at here is I have a rectangle. And with the rectangle, I have three different ways to measure it right here. You may not even see this teeny tiny little piece right here. And I know it's not a perfect square, but we're going to pretend it's a perfect square. And if I'm measuring this rectangle right here, and I take a look at this and I say, okay, I need to figure out how much area is in there, how much wrapping paper will cover this little area right here. I want you to look, what would probably be the best thing to measure that with? Well, in this case, we have, I would say, two possibilities. We could either use the blue square and measure how many blue squares it would take, or we could use the pink square. Now, yes, I could use this little itty bitty green square right here and try to push it up onto there and say, okay, well, let's put these next to each other and try to figure out how many are there. But the first thing you need to do when you are looking to measure square area is, what size are you measuring? If this was a swimming pool, I wouldn't want to measure it in inches. An inch is only this long. Here's an inch from here to here. Yet a swimming pool would take up an entire backyard. I don't want to measure in inches. I might not even want to measure in feet because a foot is only this long. I could. I might want to use yards, which are 3 feet long, and say, okay, every 3 feet is a yard. And that way, how many yards, how many square yards is the pool in terms of area? So the first thing we want to do is look at and say, okay, what are we going to measure with? And in this case, I'm going to measure both with the blue and the pink and give you two different areas. Once again, like fractions, the size of the rectangle is not going to change. It's just how we measure it and what we use. So if I were to use the blue, which is the largest, I would put this up in the upper corner and I would say, okay, that's about 1. And then I would say that, okay, this ends about here, so I can put this right here, and that's about 2 square units. And these are blue square units. I have 1 up here and 1 down here. You can see the sizes right there and there. If I'm going to measure next to it, I don't just estimate and put this over here and go, okay, that's about right. So I guess there's about 4 here. I don't know. I can't tell. What you have to do is you have to line these up side by side. So in this case, if I'm going to line this up, I need to be able to say, okay, I've got 1 blue one right here. All right, and I've got another blue one right here. I need to go right next to it to measure. I need to be right by the side of it. And there's another one, and I can kind of make it like this. And then this one would be another one. I know, again, I'm not perfect. And lastly, these two here. We'll go one about here, because this would be about here, and this one about here. So as an estimation, we can see that there are approximately 6 large blue squares. So for blue, which is turning purple here, we have about 6 square units. That would be our blue, 6 square units. Now, if I want to look at pink, I can do the exact same thing. The pink, I would be able to go, okay, I have 1. I'm going to show you a shortcut here. And I know there's 1 right here. And now I'm going to go down another one. There's 2. There comes another 1. There's 3. And lastly, 4. So this would be 1, 2, 3, 4. From here to here, from here to here, from here to here, and here to here. I have 4. And I know that this will go all the way down like that. Sorry, it's hard to draw. I have things on the side here. All right, now I'm going to go across. So this is 1, 2. I'm going to go 3. Draw another line. 4. Draw another line. 5. Draw another line. And I know that this didn't come out exactly right, but it should come out to about here. We're going to pretend that these are all the exact same size. It was measured out. Now I can go across. I know I'm going 4 down and 6 across. What is 4 times 6 for pink? That would be 24 square units. Now, we got 2 completely different areas here. I didn't change the rectangle at all. I just used different size squares to measure. And that can happen when you're doing area. So you have to be careful with what you're actually measuring. Keep an eye on what you're using. You can also do another little, I won't do, actually, let me rephrase that. Let's get our little guy out of here, our little useless guy who could be used. I want to look at one of today's problems as I take that back. This is the back page that you will be working on in the colored pages. So notice that Danny is placing tiles on the floor of an office lobby. Each tile is 1 square meter. Well, a meter is about 3 feet long. It's a little longer than that. So these would be huge tiles. And these tiles that Angie is using are 1 foot. Since we're just looking in a book, you don't have to worry about it. But these tiles on the floor would be big like this. These tiles on the wall would be smaller like this. In other words, Danny is using big blue tiles for the floor and Angie is using small pink tiles for the wall. It doesn't matter. We're still going to be measuring square area. So if Danny is placing tiles on the floor of an office lobby, each tile is 1 square meter. That's a square meter. That's a square meter. That's a square meter. That's a square meter. What's the area of the lobby? Well, we would just count at this point. We could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 12 square, and then look at what we were measuring, meters. So we could put an M for meters. This would be the area of the lobby. Now, you have to be a little more careful with Angie's. On Angie's question, they want to know how many more square feet has Angie painted than not painted. Okay, well, how many square feet is there all together? You have to figure out the total. Well, we have 1, 2, 3, 4, 5, 6 across. And we have 1, 2, 3 down. 6 times 3 is 18. That's her total. But that's not the question they asked. We know there's a total of 18 square feet. And I better put my SQ feet for this problem. We know there's 18 square feet total, but it said how much more? Well, if there's 18 here, we can kind of see that she has done 2, or she needs to do 2 more, and 16 of them have been painted. So she's painted 16 painted, 2 blank. So we're going to take those away from each other, because how many more square feet has Angie painted than not painted? This is not painted, this is painted, and we end up with 14 square feet more that has been painted than not painted. Okay, try to do these. This one down here is a little tricky. It's going to ask you to imagine. So here we have, and feel free to stop this video and go back and rewatch it at any time. This last one here is a bit tricky because they are going to give you 1, 2, 3, 4, and 1, 2, 3. All right, so this is my attempt at this picture. It says how many squares needed to be added to this figure so that it has the same area as a square with a side length of 5 units. Well, this is what I like to call the missing pieces puzzle. There are missing pieces here, and right now we only have some of the pieces. We need 5 on the side, so I'm going to dot this in. This would be 1, 2, 3. I'm not done yet. I need to go over here and go, now I have 1, 2, 3, 4, 5. Remember, I have to have the same as an area with a square of side length 5 units. Well, a square is going to be the same on all sides. This is 5, so this also has to be 5. That's why I wrote 5 there. So I need to, in black, add another layer. And I still don't have a square. I need to go one more again. All the black ones are missing. When we first started, we only had the green ones. They wanted you to find how many squares are needed to make it the same area as a 5 by 5. Well, we know that 5 up and 5 across is going to be 25 square units. But you had to fill in these missing pieces to get to a 5 by 5 square. So how many pieces were missing? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 missing pieces. 12 missing square units. That's how to do these problems. When they only give you part of it, you have to think of how big do they actually want you to make it. They will always tell you in the problem itself, but it does require some thinking. Okay, I will probably be doing a live Zoom on one of our math lessons in the near future, and I think that will also help. But today, feel free to rewatch this video as well as watching the math on the spot, and hang in there.